to take a second to remember what kind of supply chain inferno apocalypse was 2021. I Obviously there have been massive disruptions related to the pandemic. We saw massive ports in China slowing down because of the virus and the spread of infection themselves. But we also saw other kinds of impacts. We saw India slowing down extraction of raw materials to divert the oxygen used there into the healthcare sector. We saw things unrelated to the pandemic, the Suez Canal blockage. We saw suspension of railroad between the West Coast and Chicago. And all this kind of disruptions, together with climate-related disruptions like Ida, storm in Texas, wildfires in California, all of these, I would say, unprecedented accumulation of events, adding to an increasing commitment of the industry to reduce their supply chain footprint and also dependency. And I think it's very important to conceive that we don't have anymore the luxury to think of these events as just possibilities. They are here and they're happening all together. I think this is what 2021 showed us in great terms. And I want I'll jump now into how additive manufacturing can help reduce reliance or exposure to such risks. It's sometimes on-demand manufacturing is used interchangeably with additive. I'll stick to additive in this case because I think what's happening there is revealing. Before we go into the specifics, just a quick overview on where additive has shown to be has proven not just as a conception, just theoretically, but has proven to deliver significant added values. So when we are talking about the introduction of a new part, a new product, I think additive has proven there to make sense in the low volume, high mix end use parts. And also in cases where complexity is a predominant characteristic of the part. We often say that complexity comes for free in additive. This is for sure not the case in traditional manufacturing, but also other use cases with very important track record are jigs, tools, fixtures at the production line, and spare parts. I'm gonna touch on the supply chain implication and potential benefits of additive for each of those. Allow me to start from, but not in that order. Allow me to start from tooling. This is an example from Stanley Black & Decker. What we see here is a machine in their facility in Danbury, which produces these very tight helicoils for the automotive and aerospace industries. And what Stanley did, it was looking into reducing, exploring benefits both regarding cost and time in this facility. We went through this journey together, and what we did is to assess which of the parts that are involved in this production line, in this machine, can be produced in additive first of all, from a technical perspective, but also makes sense to produce in additive from an economic perspective. And we identify this part here. We see it in action. We see it in a close-up on the right, as an opportunity to 3D print as is. And the interesting part here with regards to the supply chain is that they usually would source this part in traditional manufacturing at about 2 months, 9 weeks. And they were able to get the part in 9 days. I want to stick to this part. I think it's very revealing with regards to the shortened lead times. Um, and the possibility, of course, to source the part in big proximity and reduce exposure to risks related to the supply chain, to transportation. This is also happens to be also a cost reduction opportunity. They were able to get the part at half the price. But I think also when on specifically there is no cost reduction associated with the use case. Let's say in a tooling case where 3D printing could come more expensive for the production of the part, but in the grand scheme of things could be a cost saver because of the avoidance of downtime. So I think it's a very tooling specifically, and tools, jigs, fixtures, and parts used in the production line are a great candidate and a very prototypical case on how additive can reduce exposure and to the risks of traditional supply chains. I'll move a little bit now to the economics and how the supply chain benefits come into play there. We talked earlier about the very classic cases for additive, which is spare parts as well as new parts, new products introduction. And I want to take a look at this graph. It shows it's a very popular representation of in which cases, from an economic perspective, it makes sense to 3D print. So we said again, low volumes are the sweet spot. But let's look a little bit about at specifically the hidden benefits of additive manufacturing. And to do that, what this graph doesn't capture is the supply chain aspect. So what I mean is that we have seen cases, and we see cases that the production costs, if put next to an additive, put next to the production cost in traditional manufacturing, might sometimes be the same or a little bit higher. But when we look into the total cost of ownership, the situation can change significantly. So I'll stop for a second on the case for a new product. Looking only to the production part per se of the part might be missing expenses associated to pre-production aspects such as tooling. So when we have a new part that is possible to be produced technically in additive, when assessing the economics and what is the business case, we must take into consideration investments in tooling. And what we could see there, and how this graph could shift, is that the cost, let's say this is about 100 parts, the break-even point for a part of $5,000, we can see the break-even point shifting by 20 or 30%, depending on use case. Don't quote me on the numbers. It's just to exemplify that we can break-even point thing because of the tooling cost taking into consideration. And that is for the introduction of a new part where the investment on tooling hasn't taken place yet. So when assessing additive or traditional, we should not only look into the production costs, but also to the total cost of ownership. I want to also stop for a second to spare parts. There, the case is a little bit different because tooling costs have already been incurred. But it is important when assessing whether it makes sense to print a part versus traditional manufacturing to take into consideration the inventory cost. And we can see again a shift of this break even by taking into consideration the inventory costs. And I will be a little bit more provocative here and say we have been discussing until, and I have been talking until this very point about traditional versus additive. But some recent a recent analysis I've been delving to is talking about additive in conjunction, in tandem with traditional manufacturing. And an interesting use case there is obsolete parts, where companies are called to make a last buy investment. And what could be interesting to look into is sourcing part of this last buy on traditional, and a smaller part on relying on additive for their spare parts obligations. So what I think is the next question is, okay, great, we it makes sense to look into this use case. Okay, but where, how to identify all those parts that make sense to 3D print? When does it make sense? When is it possibly from a technical perspective, but also makes sense from an economic perspective to 3D print? So this are some insights from Castor. I didn't mention in the beginning, Castor is a software company. The our core mission is to go through thousands of parts and identify those that make sense to 3D print technically and economically. And what we have concluded after analyzing about 30,000 parts in the last couple of years is that about 10% of those parts can be printed without changes. And about 30% can be printed with some changes. The remaining are other parts that are technically unprintable or doesn't make a good business case to print, such as, for example, it can be off-the-shelf items in an assembly. Again, I guess the question that comes into play is, great, how to identify that? As I said, as I mentioned a second ago, the approach we are taking is both a technical approach, but also an economic approach. We believe that an integral assessment must take into consideration geometry, and specifically assess in detail wall thickness. It has to start from material and mechanical properties and comparison of material between traditional manufacturing and additive manufacturing. There's sometimes trade-offs to be made there, but they are really worth a deeper look. And that is the approach we take also through our technology. And identifying that sweet spot that I showed earlier on, it's very, very similar, the approach we take, identifying this break-even point where additive makes sense. I and specifically there, the approach we take at Castor is to go beyond just the production cost analysis and the break-even comparison between traditional manufacturing and additive manufacturing. We strongly believe that assessing the total cost of ownership can reveal significant benefits stemming from the supply chain in additive. And I'm just bringing in here an example of an analysis where, as I said, it's not clean cut. The production cost is exceeding the casting cost in this case, but the total cost of the part is still lower, taking into consideration supply chain aspects. So to recap, there are significant supply chain benefits that are hidden in the economic analysis and making the business case for additive. For new parts, as I said, it's very interesting to see how tooling comes into play and might shift the scene. For for tooling specifically and jigs, tools, fixtures used in the production line, speed might also make the case for economic benefits rising from a reduced risk for downtime. And in spare parts, it's important to look into not only not to stop on the production cost, how much does that service bureau charge for that part, but how much it would cost you to manage the inventory of those parts. I hope my thoughts were added some value on your additive manufacturing journey. Please share your questions, your objections, or your experiences to the extent that they relate to what we discussed here today. And thank you very much for your attention so far.
Hi, Angeliki. Thank you so much for the presentation. It was very interesting and very useful for everybody that is looking into 3D printing production. It was very striking, your data about from all the parts that you receive, about 60% unprintable. That's quite high. We should reduce that number, but of course that's why design for EM is so important. I don't see any in the Q&A tab. I don't see any questions, but I have a questions about Castor. How does it work, your platform? Is it an online platform? Is it a service if somebody wants to use your tool?
Thanks a lot, Nadia. If I can, before I go into Castor, or rather, I will address both your points and your observation by explaining how Castor works. As I said, our goal is to go from this huge pool of parts that a company is dealing with to those that it makes sense for the engineer to take a deeper look for additive. The core capability is being able to go through thousands of parts at once. And that, I think, touches a little bit also on your observation about the 60% being unprintable. So what Castor can do is you can throw in the software a very large assembly, And the software will break down and analyze each part, and identify the right material to print this part. It will present a comparison between the properties of the traditionally manufactured material and the 3D printable material. There, the engineer will be able to gain confidence on and understand potential trade-offs that need to take place between the two production methods. We also check the geometry of the part, and there we assess the wall thickness of the part, but also we assess whether the part will be able to be printed and usable in real life. What I mean is, are there areas that is hard to remove support? We will assess that. We will assess tolerances. But on this technical analysis, this is where the 60% comes into play. It's important to know that the software also has the capability to assess, for example, in a large assembly, which parts are off-the-shelf parts. It will detect those automatically. And there, I think that affects also a little bit the 60% number. From a technical perspective, we will do exactly what I presented a second ago, which is to identify the break-even point between traditional manufacturing and additive manufacturing. And we will not only stay at the production cost, but we will provide a transparent breakdown of how pre-production costs related to tooling or inventory management costs coming to play in this economic business case analysis. With regards to how the software can be used, the software can be used on premise, it can be used on the cloud. It is designed in a way that it won't that considerations related, which are very strong in this industry, related also to using cloud, won't be an issue. And that means, yes, you can use it locally on your computer, you can use it as a platform. But Castor is a software company. What we offer is this capability of analyzing thousands of parts at once. It's not a service company, but that doesn't mean we just give you the software and run away. We'll be there in the journey, along the additive manufacturing journey, from the beginning until the end. I think it's important to recognize also in this industry that pure 3D printing evangelism is not going to cut it. This is not an ideological war. Is about transformation, is about thinking, as I said earlier on, of additive in conjunction with traditional manufacturing.
Absolutely. And who are you? Who are your clients? I'm curious. I think many here are curious to know who is using right now Castor.
Right. So the clients span from across the industry. I can mention automotive, I can mention machinery, I can also mention additive manufacturing companies like Evonik or Nexa 3D, for whom we have developed tailored tools that help assess printability in their own technologies.
That's amazing.
But I think the interesting, or perhaps the connection with the discussion earlier, is additive makes sense in low volume, high complexity, and the industries that have to deal with these kind of parts are Castor clients. That doesn't mean that, as I said, automotive is part of it, but automotive is also very progressed with regard to additive manufacturing thinking. So they have already identified the cases, for example, tooling, that it makes sense to use 3D printing. But yeah, as if I can recap, automotive, machinery, but also AM players, material manufacturers.
We also have a question from the audience from how can AM business consultants use your software to consult their clients? So you have here a new client, potential new clients.
Great. So please, Gregor, reach out to me on this platform, but more generally, the software can help, can be a powerful tool in the hands of a consultant. The goal is not to replace the human brain with this software. The goal is to use this software to scale the additive manufacturing identification of parts, meaning they can use the software to analyze not large numbers of parts that their client might have never thought of 3D printing. We are not aiming just to those very prototypical 3D printable parts that are top of mind. The goal, by the capability of analyzing thousands of parts at once and automatically, is to unearth those unpopular outsider parts that can make a significant impact, both in terms of cost and in terms of speed. So what I would say to Gregory is that you can use the software, you can really drag and drop assemblies in there and find which of your clients' parts could make sense technically and economically to 3D print.
Awesome. Thank you so much, Angeliki.